Good morning. Let's continue with our discussion. So, K, equilibrium constants, um, particularly with a strong acid, strong base, and then a weak acid, weak base, and then soluble substances and insoluble substances. So, we'll solve another problem so that as we discuss things, you will be familiarized. Uh, how are we going to do away with problems? So we have a problem here. What mass? So the problem is in grams of barium iodate, BaIO3, multiplied by 2 can be dissolved in 500 ml of water at 25 degrees Celsius. So this is an so for you to uh, categorize the problem, barium iodate, you should look for a value of KSP if it is insoluble, or you go back to your soluble insoluble table. But as far as I can see, I'll just go directly with the um, table of KSP. If it is found there, then basically it would be an insoluble one. So even though if it's insoluble, meaning the mass of the substances that will be dissolved will be really be small. Okay, or maybe it's a it has a medium solubility. So let's see. So I have here a table that I have prepared to give you as your cheat sheet. Of course, you will not you should not memorize tables. So may I open equilibrium? I think this one KSP. So barium iodate. You will look for barium. This is barium. Oh, wala si barium iodate. Maybe we can look at other table. So this is the table that I will be displaying on Google Drive, so you can look for it. Weak acid, weak base. Okay, barium. How about the here? Barium, no. So this is acid. Acid solubility product constant here. Oh, ito si barium iodate. So meron siya dito. So basically, ito siya. BaIO3, 1.57 times 10 to the negative 9. So, 1.57 times 10 to the negative 9. May I pull a paint where I can put my solution? So, the KSP, so, biomarine has KSP. So, basically, it's an insoluble substance. Or insoluble, but it has actually a solubility. That's why it's included in the solubility product. Pero maliit siya. That would be, the more na mas malaki yung exponent mo, actually, the more na mas maliit yan siya. Of course, because you have a ratio of your product over reactant. So, pag malaki yung reactant, meaning hindi masyadong marami yung nadi-dissolve, yun yung ibig sabihin. So, pag malaki dito, malaki yung nasa baba because that is inversely proportional. Malaki na negative. Sorry, malaki na negative. Okay? So, 1.57 times 10 to the negative 9. 1.57 times 10 to the negative 9. So, KSP 1.57 times 10 to the negative 9. So that is the KSP of, so this is the KSP, solubility product constant of your barium iodate. So IO3 and then 2. So again, we can represent this as a dissociation reaction. So let's first represent this in terms of a dissociation reaction. So that would dissociate. So you have two arrows for this when it has a KSP. Then you will have a barium. You can go back to your table of ions. I think this is barium 2 plus. And then your iodate is a negative 1. if I am not mistaken. And maybe we can look back to our table of solubilities. Solubilities, nandito yan siya sa ito, atomic ions. So, barium iodate. Unahin mo na si iodate. Ito. Si iodate. Ito. So, iodate is IO3 negative. So, basically, kasi pabaliktad to siya, so you can expect that iodate is negative 1. So, barium should be a positive 2. Kaya nag-multiply 2 siya dito ng 2. So, dapat alam nyo to dahil previous topic na natin to. So, it should look like this. Okay? Meaning, makakasulat kayo dapat nito. Sir, bakit namin kailangang isulat yan? Kasi importante yung mga coefficient dyan. Okay? So, balikan natin yung question. Yung question niya is, what mass in grams of barium iodate? So, yung makukuha natin muna is yung solubility or molar solubility muna. Kasi meaning, yun yung matutunaw in terms of mole per liter. Yan yung S usually I think, nag-solve na ako nito sa face-to-face. Sabihin na natin that is S. Yung S actually, yun yung solubility, yung matutunaw nito. Pero pwede to siyang makuha dito sa product. Depende sa problem. Yun na, depende sa problem. Tulad nito, you have 1 barium iodate, you have 1 barium. So, ibig sabihin, yung S mo is equal din sa equal din. Ha? Hindi siya yan, but equal din. Kasi maghihiwalay siya, pareho din yung dami. I mean, it has the same moles of barium. So, you can say that the solubility of barium iodate or barium iodate is equal to the concentration of barium 2+, which is also concentration of iodate, but you have to divide it by 2. Why? Because for every barium iodate, there has 2 moles of iodate. So therefore, you have to divide the concentration of iodate before you can get the solubility of barium iodate. So that should be an iodate. Okay. So 1/2 the concentration of iodate. Okay. So na-establish na natin to. Again, di nyo ma-establish to kung di nyo ginawa ito. That's why it is important. Okay. Next. We want to compute this one. Because this one is this one. Actually, ito yung kailangan natin, but pwede natin kunin dito. Okay? From the chemical reaction. So, as I've said, this is solid, usually, for ions. So, that is solid. So, meaning, if that is solid, your KSP expression, nawala. Yung KSP expression mo is equal to barium 2 plus multiplied by iodate. Yan. Raised to the power of 2. So, ito na naman, galing yan dito. So, kaya importante yung balance equation mo. Okay? So, over dito, kaya lang solid siya, kaya tinatanggal. Pag solid liquid siya, tinatanggal siya sa equation. Bakit? Kasi unity or 1. Malapit sa 1 or 1 yung value ng molarity mo. Yun siya usually. Mababasa nyo yan dun sa binigay kong reader. Okay? So, next, after you establish this one, we plug the KSP, which is 1.57 times 10 to the negative 9. So, and then, we can, if we want to get this one, so we should be equating iodate into barium, which is this guy over here. Okay? So, yung iodate mo is 2 barium plus. So, imumultiply mo ng times 2 yung barium ay yun yung maging iodate mo. Kasi nga dito sa paghiwalay nila, dalawa yung magagawa nito, dito isa lang. So, i-multiply mo dito, yun yung magagawa na IO3, iodate. So, pwede mo na siyang palitan. You have barium 2 plus and then you would have yung 2 times barium 2 plus. Kaya lang, ano to siya? Naka-squared. Yan yung square dito ha. Kasi ito, pinalitan natin ng ganito. Kita nyo? And then that would be 1.57 times 10 to the negative 9. Then, papasok to siya, magiging barium 2 plus. Then, ito magiging 4. And then, barium 2 plus squared. So, itong dalawa, pwede mo itong pagsamahin. You have barium 2 plus cube. Tapos, yung 4, ilagay mo dito. So, that would be 1.57 times 10 to the negative 9 divided by 4. Okay? So, by that, calculator na lang to, makukuha mo na yung concentration ng barium 2 plus, which is the cube root of 1.57 times 10 to the negative 9 all over 4. Um, 1.57 exponent negative 9 all over 4. And that will give us 7.32. 7.32 times 10 to the negative 4. Therefore, this unit nito is mole per liter. So, yung KSP, hindi yan nilalagyan ng unit because understood na yan, iba-iba yung unit kasi niya. Depende kung ano yung chemical reaction mo. So, alam lang natin na pag dinisolve na natin sa concentration, that should equal to, the unit should be mole per liter. Yun siya. Okay, so pag alam na natin yung solubility natin ng barium iodate, meaning yung matutunaw na barium iodate is equal to 7.32 times 10 to the negative 4 mole per liter. So, balikan natin yung problem, yung matutunaw, yung solubility. Di ba? So, balikan natin yung problem. Sana yun? Ito yata. So, ngayon, ano daw yung mass? Binigay yung molar mass niya. Kasi nga, magka-convert tayo from mole to mass. Tapos, binigay kung ilan yung solution. So, kung ilan yung solution, i-multiply muna natin dito. So, ibig sabihin, pag gusto natin yung N, diretsohin na natin, yung mass ang gusto natin, i-convert na lang natin to. 7.32 times 10 to the negative 4 mole per liter. Multiply natin ng ng 500 ml or 500 times 10 to the negative 3 liters. So, makukuha na natin ng mole ng barium sulfate. Mole na to ng barium iodate, sorry. Barium iodate. And then, i-convert din natin yung mole to mass using the molar mass that was given. That would be 487 gram per mole. Okay? 487 gram. Baliktad. Nandito siya dapat sa taas. Control Z. So, tingnan nyo na lang yung unit. 487 grams of BaIO3 to per mole of BaIO3. So, cancel siya. Cancel. So, yung mass, makukuha nyo na. So, that would be times 500 exponent negative 3 times 487. Chedeng, and the answer is 0.178. 0.178. So, masyadong maliit to actually. Maliit to siya. You could just imagine, yung 1 gram mo, yung 1 gram kasi parang muta lang yan sa, lalo na pag mga, you could just imagine yung betchin mo, you try, yung 1 gram mo, palagay ko, parang, sa isang kutsarita, baka mga 1/5 niyan, yung dami niyan. Tapos, hindi siya nakabukdo. Yun yung 1 gram. So, sorry, yung unit niya is grams na to siya. Grams. Sinabing milligrams, in grams. In grams. So, grams na siya. So, 0.178. So, i-divide mo yan ng 10. Then, you would have somewhat divide ng 5. So, mayroon kang 0.2, which is malapit dito. So, maliit talaga yan siya. Parang nag-drop ka lang ng ilang bottle sa 1 litrong tubig. Yun lang yung pwede niyang tunawin. Kaya, sinasabi natin, insoluble sila. Kasi pag mag-drop tayo ng marami, di ba, yung asin, you could just imagine yung asin na soluble, pag mag-drop tayo ng kahit isang isang kamay ng asin, ilagay natin sa 1 litrong tubig, most usually baka lahat yun matunaw. Kasi tinatawag natin silang soluble. While ito, 0.178 lang yung meaning hindi natin yun masyadong mapupuna. Okay, kaya yun siya. 0.178 grams. Okay? So, thank you guys for listening. So, putulin ko lang para hindi masyado mahaba.